This one's number, or a version of number 13 on 3.3. So it's solving an inequality with an absolute value. It's a greater than, but this one has a little trick to it. So let me show you where this gets a little bit funky. So the first thing we would do is isolate the absolute value. So I'll subtract this 20 over. And that's going to give us 2, and then absolute value 2b plus 7. Those cancel out, and then this is going to be greater than or equal to negative 18. And then if I finish, and I don't even need to do this step, but if I finish isolating that absolute value by dividing out the 2, oops, there we go, then I'm here, 2b plus 7 greater than or equal to negative 9. Okay, so the absolute value of 2b plus 7 is always greater than negative 9, because no matter what value I put into this, if I put negative a million in for b, the absolute value of negative 2 million plus 7 is a positive number, because when we take the absolute value, it always comes out positive. And so that is why this one is going to be all real numbers. So our solution set would be negative infinity to infinity. If you think of this graphically, this is asking, so this is some, let's see, it's got a shift. It does come down to 0. It would look something like that, and that's obviously incredibly approximate. When is this thing greater than, when is it above negative 9? Negative 9 is down here. There is, any value x I put in for this function is going to come out bigger than negative 9. Because again, that absolute value, if we have it all solved out, the lowest it could possibly be is 0. So that would be always, or negative infinity to infinity. If this had happened to be flipped around, then this would be a no solution, because this thing would never be greater than a negative number. And so those are kind of the two exceptions, is when you do have a negative on this side, that's where you have to watch out for those two cases.